Let's start out with a little bit about Python. I talked a little bit about it last time, but I want to go a little bit deeper and give you a little bit of history and context and a little bit of information about what's unique about the Python language, because I think that's useful information moving forward. And it's just good to know before you dive into studying a language to know sort of its origin and what it's about. So this is the man, Guido van Rossum. That's his real name. He's not from the United States. He was working in the late 1980s. He's a scientist, and he built Python because, like many of the folks in early computing, the tools that were available just weren't doing what he needed them to do. Most of the biggest advancements in computing have been developed to, as they say, scratch their own itch, the people who invented them. So, in other words, people build these things a lot of times to solve a problem, not for the whole world or to invent the next greatest language, but just because they needed something and they decided to build it themselves. So he used a few other languages that were used for scientific computing as his sort of basis for Python, and then built something that was more along the lines of what he needed. It quickly took off from there. Why? What's so great about Python? Number one thing, and this is something we can all be happy about, is that it's easy to learn, right? So it's easy to learn primarily because it uses more natural language. When you look at Java or C++ or C, or heaven help you if you're looking at assembly language. Anybody ever looked at assembly language before? Or anything along those lines. Assembly language is very closely adjacent to what computers actually speak. And so when you look at it, unless you're very seriously trained in the use of assembly language, you won't have a clue what it's saying. But with Python, it's a little bit different. You can look at a Python program and you'll actually see words that make sense, words that you'll recognize, like print or for each, or loops and things like that. They make more sense than a lot of other programming languages. And Guido van Rossum actually purposefully built Python that way because he wanted it to be usable by people who weren't computer programming experts. And that's a great thing because it sort of lowers the bar, makes it a little bit easier for folks like us to learn computer programming using Python. As you'll see in this class, it's a very versatile language. It can be used for all kinds of things. We'll get into some of the specific uses in just a minute here. But one of the biggest things about Python that makes it so powerful and so great, and honestly so fun, is that it's extensible. What that means is if you find yourself down the road sometime wishing that Python had a module that could do something, no matter what it is. If it had a module that could connect to a camera and recognize what kind of dog was in the camera's picture, or recognize a face. A lot of these things have already been done, by the way, but that's beside the point. If you had this great idea for something that would be just outstanding, if Python could just do that for you, you could actually build that using Python or a whole bunch of other possible languages. And you could actually extend Python and create functionality that allows Python to do those things, which means the possibilities with Python for what you can do are almost infinite. And there are very few languages where that's actually true, especially in the sense that Python makes it so easy to do that. The last and really another very important thing about Python and what makes it so great is that it's got such a huge user community. So many people are using Python out there in the world that if you want to find information on Python, or you want to do something with Python, or see if a module exists for Python, just Google it. And you'll see there are almost always other people out there trying to do the same thing that you've done. Sometimes they've succeeded, sometimes they're still trying to figure it out. But the great community of users out there that use Python and share information about Python makes it a really great language to learn, because having other people that you can collaborate with is great in almost any kind of situation, right? So in terms of computing, it's really a big deal. So where is Python used? You've heard me say that my son has used Python in various internships and jobs as a software engineer at Microsoft. But these are just a few of the other big companies that regularly use Python, not for research, but in actual production software, meaning there's Python code under the hood of every one of these companies' primary software products. That's a huge deal. That means if you're a Python expert, you can be programming code for one of these companies in Python. That's pretty cool stuff. There's some big ones there, right? Google, Instagram, Pinterest, Amazon. I hear that's a pretty big company, right? Up and coming. They're doing pretty good. They might be around for a while. I literally order almost everything I own from Amazon. Why would I have to leave my house? So what kinds of things can you do with it? You can do web development, data science, machine learning, artificial intelligence, robotics, game development, scientific computing, databases, embedded systems, Internet of Things. You've heard of the Internet of Things, right? It's when you can connect your toaster to the web so that you can remotely toast things on your way home from work so that your toast is ready. Really important stuff, but fun, right? And the Internet of Things, the idea of Internet of Things has been around a really, really long time. In fact, in the early 90s, there was a Japanese trade show that showed an internet-connected home. And it was sort of like the home of the future at that time. A lot of the stuff in that home has materialized. Some of it has not. For example, the toilet that analyzes human waste to see if you have any medical issues. That one, there are some privacy issues around, and some maybe recognizing who's sitting on the toilet at any given time, or if you have kids, all kinds of things go in the toilet. Who knows how? So there are some issues, but they're not technical issues, they're practical issues, which is ironically very common in solving technological problems. One last thing about Python. We're not going to get into nitty-gritty details of how computers work here, but there are really two major categories of programs. One is called a high-level language, and one is called a low-level language. Bet you didn't see that coming. The low-level language is a language like C or C++, where that language, when you write the code and you're done and you're ready to test your code, you actually take that code and you use something called a compiler to translate that code into machine-readable language. And at that point, that file that the compiler produces is no longer readable or editable by you. And that file is what you execute or what you run so that the computer can do its thing or to see if it works. The advantages to a low-level language, because they're compiled into a language that the computer already understands, is that they tend to be a little bit faster. Okay, they execute faster, there's less overhead, that sort of thing. The downside, of course, is that the development cycle is constantly interrupted, because every time you make a change, add a semicolon or whatever, you got to recompile the program, retest it. So testing and development cycles become much slower. It used to be that most languages, because processing speed tended to be slower, more languages tended to be low-level languages when you're talking about writing production-level code. But I think that's shifting now. I think that our interpreters are getting faster, and our computers are getting faster, and we're starting to see more languages like Python used on the front lines in production situations. A high-level language means that your program, with its PY extension, is actually sent to an interpreter. That interpreter speaks to the computer on behalf of the program. So it's just like a foreign language interpreter, if you will. So it speaks both Python and computer and translates between the two. And what you get on the other side is the output of the program. But there's some overhead here in terms of the computing power. Some of it is wasted on the interpreter, but not so much that we have to worry about it in every instance. If you've got a program that's a really high demand, really high workload, then you start to care about some of those things. And those things are still written in low-level languages because they have to be. When it's something like Google's core search functionality, you can't write that in Python, because if you write that in Python versus a low-level language, there's an actual cost to the company. That the slowdown of using an interpreted language versus a compiled language could cost the company hundreds of thousands of dollars per month when you're talking about the kind of traffic that Google is doing. So you could literally bleed money just because of your language choice. So that it does come down to money. It comes down to electricity usage. It seems crazy, but if any of you follow Bitcoin mining, you know that there's a relationship between processing, high-level processing, and electricity usage. Because if you have a little Bitcoin farm operating in your house, what you're going to see is a spike in your PG&E bill, because those machines are just cranking nonstop, just doing calculations. So Python is great. Python's a great language for learning. It's a great language for a lot of situations. Not a great language for every situation. I don't think that exists, though.